In this video, I'm going to teach you how to mask out clouds from Landsat imagery. This is especially helpful when you have an area that has a lot of cloud cover. For example, I have drawn an ROI in Peru, in a region where there is cloud cover for a lot of the year. So in these sorts of areas, it can be really difficult to get a cloud-free image. I've started out in my code by just trying to filter the Landsat 8 image collection by this cloud cover property to get less than 20% cloud cover. This cloud filtering technique doesn't actually work too well here. Instead, I'm going to try a built-in function in Google Earth Engine called the Landsat.Simple.Composite. We can look in the Docs tab to learn more about the simple composite. Click right here. So it says it computes a Landsat top of atmosphere composite using a collection of raw Landsat scenes. It applies the top of atmosphere calibration and assigns a cloud score. What it will return to us is an image where it has eliminated clouds as much as possible. In order for this simple composite function to work, we need to use the Landsat raw scene. So Landsat 8 raw. I'll import that and name it Landsat 8 raw. And then I'll create a new variable. I'll call this Landsat 8 raw filter, where I take that raw image collection and filter it by the dates and by my ROI. I'm then going to apply this algorithm. So variable Landsat 8 simple composite, and I'll write this algorithm name. And then within these parentheses, I'm going to put this Landsat 8 raw filter variable that I created up there. And now I can add that to the map. Remember that there are different band names for the raw and top of atmosphere images. So rather than SR, we need B4, B3, and B2. I'm not sure what the min and max will be yet, so I'm going to leave that blank and then I'll enter it in a second. And I'll call this layer Landsat 8 Simple Composite. Let's run that and see what it looks like. So clearly the image is quite dark. Let's go in here and do 100% stretch. And we can play around with this to see what a good stretch might be. All right, so I am going to hard code this. So I'll put min 0, max 60, and then we can run this again and look at it. The image clearly has a little bit of a blue tint. Remember that this is a top of atmosphere image, so there are still some haze effects that we might be seeing. And we can toggle between these images, and something might become clear to you, which is that in our original filtered image, we're actually missing the top part of our ROI. And that is because in this top tile that makes up our geometry, there actually wasn't any imagery that matched our criteria here. So there wasn't any imagery that had less than 20% clouds. So with this simple composite, we are getting our full ROI. We are getting a little bit less clouds. You can really see that there are less clouds in this area, but obviously we do still have some clouds here. So now I'm going to talk about how we can go forward from here and try to get even fewer clouds in our imagery. One step that we might take is expanding our month range. So if we do February to October, maybe that will give us slightly more cloud-free imagery. And I would say that this imagery is slightly more cloud-free, but sometimes we don't want to expand our imagery by the month range because there's a specific season that we are interested in. So instead of expanding the months, sometimes our research question might allow us to look at imagery between two different years. So for example, we can look between 2020 and 2021. So this date range will get imagery in 2020 and in 2021. And then I'll still constrain it by the months to get a certain season by using filter, filter, calendar range. And then I'll put the months that I'm interested in. So 4, 8, and then I specified that I'm interested in months. Let's see what that looks like. It takes a little bit longer to load because it has a lot more imagery to process. But you can see that this image is a lot clearer now. The fact that we still have clouds in our images means that there was not a single cloud-free pixel within these areas. So again, this just goes to show that this area is extremely cloudy. You could continue to modify your code to see if you can get an image that is even more cloud-free. But this depends on your research question. You might decide that this image is good enough, or you might decide that you do have some leeway in terms of what years and month ranges that you can look at. And maybe your prime goal is to get that cloud-free imagery. So it just depends, but I hope this code helps you achieve a cloud-free image.